I wouldn't say that they try to cover up, but that is a common perception out there. There are all kinds of conspiracy theorists out there who believe that somehow there's some kind of unholy alliance between the chemical industry, big pharma, you can throw physicians in there as well, to undermine the health of the public. Why? So that they can sell them their expensive, useless products. This has kind of developed curiously over the last 40 years. The word chemical has become synonymous with poison, toxin, and everything that's dangerous. And how this happened is, it's hard to say. Although I think a pivotal point was the early 1960s. The chemical industry wasn't behaving the way that it should have. We weren't very green. Substances were being dumped. But in those days, people weren't worried about those things. But now the regulations are different. And the chemical industry is one of the cleanest industries. Unfortunately, I mean, in my career, I've seen the evolution of this, kind of the fall of science from grace, and most of it based on pseudoscience and based upon junk science. So we have to right some of those wrongs and just be very transparent and honest about what is going on, because we don't have anything to be ashamed of. We do a good job, and the products that we sell are safe. But no matter what, you cannot say 100% safety in everyone under all conditions. And that's all part of the equation that we have to voice. No matter what kind of testing we do, we can never prove a negative. You can never prove that something cannot happen. At best we can show that in the test animals that we use or in the test population we used, the chance of harm is very little, but you cannot prove the negative. And, the classic example that, everyone uses is the reindeer example, and that, most of us, I think, would believe that reindeer cannot fly. But if we were asked to prove it, well, we could take one reindeer, take him up to the top of this building and nudge him off. And let's face it, if that animal ever in its life were motivated to fly, that's the moment. We'd have a mess at the bottom. You could repeat it and repeat it. What would you have proven? That those reindeer today, for some reason, could not or chose not to fly. Maybe there are some reindeer, maybe 8 of them, which under the right stimulation fly. So, it's sort of a naive expectation to think that you can prove that something cannot harm. And to what extent are we going to go with the testing? Testing is extremely complicated and extremely expensive. But luckily, we have a very good scientific base on which to make good, educated guesses. We know about molecular structure. We know what molecules are likely or not likely to do. So we can arrive at a very good risk analysis, without testing every conceivable feature of a substance.
This is linked to the sort of discussion we've been having, and it's really, will that amount actually cause any harm? And one of the things that we know about everything that we take into our bodies, whether it's through our diet, what we inhale, or through the skin, is that it is distributed through the body once it is in there, it is metabolized, and then it is excreted. So the real question is, how much is in the body at any one time, and is that causing any harm? Because generally these things are in transit. And I think because we've mentioned parabens a few times, we have done some calculations on whether or not it represents a risk. And if you assume that all of the cosmetics that you use each day all contain the maximum allowed level of the most potent of the parabens in terms of estrogenic effect, and all of it was absorbed, none of it was excreted or metabolized, it would still be 60 years before you absorbed enough to run any sort of risk of an endocrine effect. What we know is that roughly 25% of the parabens, because they're a mixture, is of that one, and the other 75% is other parabens which don't have this effect. So your 60 years has now become 240 years. How much of it do you absorb? About 3%, but let's take a sort of conservative estimate and say 10%. So we're now talking about 2,500 years of daily use of cosmetics. And during that time, actually, you don't keep it all. You do break it down. You do excrete it. And so you would never, ever, ever get to the point where using parabens could cause a problem. Because how long does it last? What you take in through the skin, half of it is got rid of in 20 minutes. So all of it will be got rid of in about 3 hours, not 2,500 years. So, these vanishingly small amounts are simply not worth the effort of worrying about. I think, roughly speaking, man has produced about 100,000 chemicals. That's sort of roughly what's on the market. Another rough estimate is that nature has produced about 60 million chemicals. We, as individuals, have never been exposed to many of those, so our bodies won't have any history of exposure to it. What our bodies do is have systems of breaking down anything. So when you absorb a chemical, whether it's from food or medicine or anything else, the body effectively says, is this stuff of any use? If it's a vitamin, that's useful, I'll keep it. If it's potentially a source of energy, it says, that's useful, I'll keep it. I'll break it down and I'll store it, and then we can burn it off and produce some energy. But if it's a substance and it says, well, this actually I don't want, this is useless. Having absorbed it, it's not always that easy to get rid of it in the same form. So we metabolize it. And we do that by breaking open the chemical and putting something onto it that makes it easier to get rid of. And the same process applies to all of those chemicals, whether they're new, man-made, or synthetic, or indeed natural. It's the same processes that apply. And the body has no idea where this came from. It just says, I don't want this one, I'll get rid of it.
The easy answer is, of course, good science matters. We wouldn't be here without good science. Safety is the most important thing that the cosmetic and personal care industry focuses on. It's the absolute basis for everything we do, and it's the most important thing we care about. It's the fact that our products are safe is recognized by regulatory authorities around the world. FDA regulation, for example, of cosmetics is the least stringent of any other category that they regulate, because cosmetics are such a safe product. Transparency and good science go together really, really well. And if the consumer knows what the ingredient is, the consumer understands the balance of effectiveness and safety, for example, in a preservative. If the consumer knows why a particular ingredient is added and why a company chooses to not include that ingredient, that goes a long way, I think, to explaining the safety of our products and to assure consumer safety in them and consumer confidence in the products.
I guess they're thinking, if it's free of this, well, what is in it instead? So, and we've asked that to companies that come and do desk sides where they're introducing a new product. They'll come to our office and tell us all about it, or we go to presentations and launches of products. And the odd time you get somebody saying there's nothing nasty in it, like parabens or triclosans, or maybe I didn't say that word right, but and so then we'll sort of say, oh, can you tell us what the preservative is then? And 9 times out of 10 they'll say, let me get back to you on that. I'm not really sure. So they're not really telling the whole story. Obviously, they may have to go back and check, and often they'll get back to us, but then sometimes they won't. And so if we can't find out, then how can a consumer find out? And I guess that's where the confusion lies.
I suppose we should take solace in the fact that we are always taking in huge mixtures of chemicals cup of coffee, I don't know how many hundreds of different chemicals there are in that. Our body deals with them one at a time. There are enzymes in there that take each individual molecule and deal with them. So whether you are having a lot of one or a small amount of a huge variety, the body can manage it. We've evolved over millions of years to cope with a diet which has huge numbers of different chemicals in it. And therefore the trivial extra that we get from exposure to consumer products it's like a flea on the back of an elephant. If we look at how a chemical may react in the body, and then look at how it may react when it's with something else, it can either be additive. If those two chemicals have the same action, then you can add the two together and say, okay, a little of this plus a little of that is the same as twice as much of any one of them. Or they could actually counteract each other, and the risk from one may be counteracted by the presence of the other. And again, knowing how those individual chemicals work, we can work out whether to subtract the risk of one from the other. Or they may even work by a complementary mechanism so that there's a synergistic effect. In other words, 1 + 1 = 3 rather than 2. But these things are not magic, they're not mystical. We know these things, we can work them out. And all right, it can be complicated when you're talking about very large mixtures, but it's not impossible. And so the comments about, oh, it's a cocktail of chemicals, well, yes, but it shouldn't be scary. You know, we know what these things can do, we can work it out. Just as actually a real cocktail is no worse for you than drinking those individual ingredients separately. You know, one is fine, 3 or 4, you're going to be in trouble.